Good morning from Flower Mound, Texas. I'm at Grapevine Lake in northern Texas. Let's talk about mainframes. This will be a longer conversation with Kip than typical. I haven't talked much about platforms, but I'd like to talk more seriously about the mainframe, because when it comes to financial systems, the mainframe is an integral platform to our systems and has been for decades now. Our systems were early on automated. Financial systems were some of the first systems automated, and they were automated in a serious manner. We did that because it was expensive to do bookkeeping associated with financial systems. And the computer did away with whole rooms full of people that didn't have to do that work anymore. The automation just saved a lot of money and increased accuracy tremendously. Just as an evidence of this, who anymore spends time reconciling their bank accounts? I think that's, I don't know that anybody does that, because effectively our banking systems have become accurate enough that we don't have to check them. If you go back 50, 60 years, because it was done by clerks, everyone reconciled their bank statement to make sure that somebody didn't add up something incorrect. 3 years ago, I kind of went off of the mainframe, became frustrated by the inability to convince customers to go modify their mainframes and to enhance and renew them and to make them do more and make them do better. The PC and cloud-based systems based upon blades and those kinds of things has just been known for a long time that those systems were lower cost. You could string enough of them together to get the capacity that you saw within a mainframe system. And so that approach clearly has taken over much of the computing world, and no doubt that it's a winner by and large for cloud-based approaches. It hasn't impacted completely the mainframe. It hasn't taken away the mainframe. In 1991, an InfoWorld writer predicted that the last mainframe would be turned off on March 15th, 1996. As I said that this week to a friend, CB Alex, he said, "Kip, we're coming up on the 25-year anniversary of the death of the mainframe then, next March 15th. March 15th, 2021, about 6 months away. It might be 6 months away from the day I release this video. 25 years since the death of the mainframe was proclaimed. That's a long time. We will celebrate the death of the mainframe. Well, we need to prepare for celebrating the death of the mainframe on March 15th, 1996, here 25 years later. What are we going to do? Part of that is to talk about this. Why did the mainframe not die? What happened to the death of the mainframe? And how have we done? How has that death of the mainframe gone? Well, it's terrible. I mean, for these large financial systems, very little of them have been taken off of the mainframe. Why is that? Let's compare this for just a moment with what goes on in other systems that have been automated in the last couple of decades that are not these kinds of financial systems. If you think about the underlying data structures that sit below the major systems of the world, the major computer systems when you think of them, what's the fundamental data principle that organizes, for example, a search engine? How is a search engine organized? The fundamental data principle is a URL. Everything pretty much in the search engine is organized around a URL. A social media site, what is the fundamental organizing principle for its data? It's a post. Everything is organized around a post. For an online retailer, what is the major organizing data principle? It's a SKU, it's a product. That's the major. Now, those aren't the only data structures. There are other data structures that work around those, but those are the major core data structures. Well, when it comes to a financial system, what is the major data structure? Well, you know it well because your credit card statement shows it to you, your bank statement shows it to you, and it happens in every business process. And by financial process, I don't just mean banking. I mean large business systems where you keep track of money, like payroll systems, accounts payable, accounts receivable, shipping, receiving, inventory. All of those things keep track of money. They're all financial systems at their core. They all have ledgers at their core. All of these systems, the data structures involved are a set of transactions and a set of balances. But the difference right there is that the balance incorporates all of the history of all the transactions. The mainframe, because it was automated early, and because the systems that were put on it were critical business systems, that errors were a problem, the error rates in those systems were driven to nearly zero. Let me give you an example. If your search engine drops a URL in response to your query of the search engine, what's the likelihood that you will ever know? How would you know that a search engine didn't present you with some results that it should have presented you? There might be ways of knowing, but it's not very common, not very easy to do. If a social media post dropped certain posts, social media platform drops certain posts, and they don't show you some post, you'll never know. If an online retailer doesn't show you certain products, well, you might know then. Last week, my online retailer wouldn't show me a particular product that I knew they had. And I was a little bit upset by that, but that's a little bit of an unusual case. You really rarely know that results. Okay, I was talking to a major transportation shipping company yesterday, a set of people there, and I said, what's the likelihood that somebody notices that that package that was shipped was dropped, that there wasn't listed, or wasn't billed, or it was lost in transit? Well, the likelihood's very high. If you're a vendor and the credit card system drops a payment due to you, are you going to know? Well, there's a very good chance you will know. You will find that out, you will figure that out, and you will be upset when it's dropped. See, the issue with these business systems is it's not about the transaction, it's about the balance. The balance is what's important. The balance is where all the processes begin. When you log into your financial system, the first thing you look at is the balance. You want to know how much am I at, what's the position at this point in time, and the balance is an accumulation of all of the activity. See, the complexity of these business systems is that they have to accumulate all of these transactions to get to the right balance, and if the balance is wrong, you're going to know it. The mainframe drove error rates to near zero. These things can run for sometimes decades without any unexpected outages. That's unbelievable. I mean, it really is incredible what these systems do, that they can go so long. It's very common to go an entire year and not have any unexpected outage in one of these systems. My laptops over the years have become better, but they're nowhere near that sort of capability, particularly if they're running day and night, full bore on their systems being used, right? It doesn't mean they don't have downtime. There is downtime that goes on in these systems, but it's planned downtime, and it's very small. In some systems, there is no downtime. There is no planned downtime. There is no downtime. They run continuously for year after year after year, and that's the very largest systems that have to do that. The mainframe drove the error rates to zero. But it's expensive to do that. It's very expensive to do that, and it was expensive to do it at the time because the systems were built at a time when a gigabyte of storage cost $7 million. So those systems are expensive, more expensive than other cheaper kinds of systems to run. But the business requirements behind those systems are higher business requirements. The lower cost hardware was not designed that way. So how do we deal with this in other systems where we try to use lower cost approaches to the problem? The machines that sometimes do give errors. I mean, it would be unexpected for someone to find a PC that has not had some downtime in a year. That just doesn't happen. And when you string together PCs in order to build a system, you build in that kind of error rate. And because we were automating systems of a less sensitive nature, when we started to string together PCs to do it, the error rates weren't really a problem. The functional requirements of business systems far exceed most of these other more modern systems we've automated. That functional requirement, when we take and we try to use redundancy on top of the functional requirement, it makes the system unmaintainable. They become too difficult to build and maintain because the error rates involved just cause concerns. Even if you can figure it out, the redundancy issues become a problem. The balance for these systems incorporates all of the transactions that have ever occurred to make the balance. That's a difficult functional requirement for these kinds of systems. We've spent 25 years now trying to get rid of the mainframe by using redundancy in lower cost systems. We've gone for 25 years now of trying to move these applications off the mainframe, and it hasn't worked. It hasn't worked. It's not going to work. It hasn't worked. It's not going to work. It hasn't worked in 25 years. It's not going to work in the next 25 years. So let's just stop it. So let's stop it. Let's stop the madness, in a sense. Why hasn't it worked? It's because redundancy is not an adequate strategy to the problem. You have to drive down the error rates in order to make the system work. And instead of all the cost we spend on trying to get them onto low-cost hardware, which cost may actually eat up most of the savings we have anyway for the higher cost hardware, let's go renew these systems that were automated so early and make them do something more important, something better. Well, okay, there's quite a bit of energy in that, but it's true. You can tell I'm passionate about it. But this is only one side of the problem, right? The other side of the problem is these systems have stagnated in the last 25 years. And it's not just stagnated from, the application side where they haven't changed because everyone said they were going to die and we were going to move them off and we'll make them new when we move them off, and that hasn't happened. So they've stagnated functionally. It's also stagnated from vendor perspectives. Vendors have stopped investing in them. Vendors have stopped renewing the software stack. These things have sat and not changed in very many ways in 25 years. In a certain sense, I think they've believed the message that the mainframe was going to die. They've taken the profits for these systems that were very highly profitable, and they've gone and invested in other things that haven't worked. They've chased the market instead of standing with confidence that error-prone systems aren't going to be able to replace what they have. Instead of investing that money in things that don't work, let's renew the platforms. It requires having courage and not acting out of fear. In some instances, executives that own these sorts of business systems are fearful that they're going to lose the profits that they've got today. Fear is rarely a very good motivator unless something's on fire. What's the positive statement? Instead of being fearful about losing control, what's the positive statement you want to make in the world? Revenue for a business is like breathing to an organism. Breath has to happen naturally, frequently, almost effortlessly. It has to happen all the time for the organism to live. But the end of one's life, I can't imagine anyone saying that their life ambition had been to breathe. That's just absurd. So no one says that. A life ambition and organization's ambition to make money is as meaningless as a life ambition to breathe. So what's a vision? I'd like to ask some of them. I've not had these discussions. This is me speaking here, not my company or anything like that. I'd like to ask them, what is your vision for these systems? What do we do next with these systems? We have systems here that have balances and transactions. What's the vision for them? We automated them early. Was that it? That's the end of the world? No, that's ridiculous, right? You know from my videos, you've seen me traveling around the world. I travel around the world and I think about financial systems, and at times, you know, I'm passing a beggar in London and I realize I have no cash anymore. We've gone to a cashless society. I can't give them something. I stopped one time, used my credit card to take out some cash so I could give a beggar some money. You know, I drive through Mexico City or through Sao Paulo or India, and there's, you know, street vendors. They're standing by my car, and I don't have anything I could buy. I don't have anything I could pay them with. All of the executives of these companies, everyone involved in business knows the power of measurement, that measurement changes our behaviors over time. Measurement is a very powerful thing that tells us what we do well and what we don't do well, what we should do more of and what we should do less of. It tells us how to specialize and use our particular talents effectively. Well, the poorest merchants in the world now have a computer. It's called a cell phone. There are hundreds of millions of these, if not billions of people that have cell phones now. Do they have a measurement system that gives them impact on and information about what they're doing well and what they should do more of and what they don't do well? Why doesn't the street merchant have the ability to, at the end of the day, look on their computer that they own and know whether they made money or whether they lost money? To know which products they sold that gave them the best profit, to know what they should sell more of, to look at a map of where they sold that week and decide where was the best place to be placed to sell the things that they were selling. All of that's a measurement that will impact their lives. Our financial systems and business systems don't do that today because they were automated in the 1960s, and that was a bit ambitious for that time, but it's not ambitious for today. So what's our vision, vendors? What's the vision about how we're going to transform these systems? What's your vision? Is there something better than that? Well, let's get started on it. Instead of fear of losing profits, let's use the profits to solve some problems in the world. I've got some passion there, don't I? This is kind of absurd. Okay, so that takes something to do it. We have to do that slightly differently because there have been changes made. The change of open source is changing the way systems work and the systems get built. Open source will change the software industry. The margins that were accrued, which are somewhat outlandish, you know, 15, 20 years ago, of 70, 80% margins, consumers don't accept that sort of margin on any product, and it's going to go away. And open source software is the means by which consumers are taking control of that margin and are lowering the cost of software. So it's going to happen. If someone will do open source and build a system that is not based upon redundancy, but is based upon driving the error rates to nearly zero for the systems, then open source could take away the mainframe as well. That's something possible. There's another alternative there, though. The mainframe vendors could begin to be more open with their systems. They recognize these trends. They've known this for 2 decades. They were early on spotters of this, and some of them have identified it sooner, and other large organizations just recently admitted that their stand on open source was wrong and that they are going to adopt open source approaches to their problem, and they're embedding Linux in the core of their system today. So that's another approach to solving this problem, is that the existing vendors move to open source things. And maybe we'll start with more the mainframers that are involved in this problem space, right? Mainframers have believed that the systems were going to die, and they've acted that way. By and large, they're quiet, older people now. They're not charging ambitious. They're not there to create waves. They just do their job knowing that they'll have a job tomorrow for the most part, because the system hasn't gone away in 25 years. Why is it going away now? Mainframers, it's time to do more than that. We need to step up. We got to take some leadership. You've done this in your younger age, and it's time to do it again. You have experience, you have capacity now. This isn't something somebody's going to pay you to do. Start with some volunteer work. The kind of vision I just outlined is something that a lot of you could believe in, helping in the world these kinds of problems. Let's get started on transforming the systems and take some leadership. Where you need to go there's things that you need to learn some new technology. The way open source works is a different way of our systems working. It requires different tools, and you're going to have to retrain yourself on some of those tools. The cloud-based approach for source code management is very appropriate. GitHub is very powerful as a source code management tool, and mainframers should need to know how it works and how to use it. Need to know how to look for open source. Mainframers need to approach their companies with these legacy systems and say, hey, this system is critical to us, but it's not a critical asset to our business. As it ages, it becomes a liability to us. Can we take this part of this critical system, and can we open source it, and can we work with others who are interested in this functionality to improve it? If we had 4 businesses that all contributed their systems of a similar type to open source, and a committee of knowledgeable individuals from each of those companies got on an open source call regularly to review their aspect of the system. What's the best part of it? What's the weakest part of it? What's the thing that we could enhance? Could we integrate these parts of these systems together doing these similar functions? See, we stop thinking we're going to take the ERP systems of the world and going to build them from scratch someplace else because they've already been automated. We won't do that. It's too expensive. The functionality that exists in the code that runs today on these systems, even if we changed the language and we converted from COBOL to Java, right? Converting from something that's a known language to another language is 1/10 of the cost of rebuilding the system from scratch. So mainframers, it's time to step up and provide some leadership. That's one thing that I think needs to happen to do this. I think also companies should be talking to their vendors and saying, open source your platform, open source your operating system. It's time. These are too critical to us to allow you to have them die for fear. It's time to open source them. And it's not just about open sourcing things, right? I have individuals who are trying to work on an open source project that I've recently become involved with, and there's no public cloud for us to work on. Can you find public mainframe systems? Not very common, right? If I go to a cloud-based system, I want to get certified in that cloud-based system, they'll give me an environment, a large environment for some period of time. They just give it to me for free. There are tools available that could be made available, more widely available, that allow you to run a local instance of Z. Can I run a VM well, you have to have a key. Oh, the keys aren't produced very frequently. We've got to go buy more keys. Oh no, this isn't a funded project for some. These people are willing to volunteer their time to experiment with the software and do something new. So release the VMs for people to do stuff with. Let's get on with the work. Let's stop messing around. Well, there's a bunch of energy for you, isn't there? This video is going to be released as part of the Open Mainframe project summit. Linux Foundation is now supporting projects that are focused on ZOS. That's a little bit of an unusual turn, isn't it? Well, it's a very good turn. It's a very important turn. It's what's going to help renew and restore this environment. What a wonderful career I've had working in this problem space. I'm passionate, it's fun. I love it. The challenges are real. I'm excited about the changes that will come, because there will be changes that come. Our systems are aging and we're going to renew them. They'll get renewed. It's what happens in the world. Old things get renewed in some way. And that's what we're going to do on these large financial systems. And it'll be fun to be part of that. It'll be fun to see how these trends that perhaps if I'm, I don't know, 70% accurate, that's a pretty good accuracy prediction of what I predicted here in this video, will help further that along. The Open Mainframe project is going to help make these changes happen. Participation by mainframers, participation by vendors would help further this goal. Customers contributing their large financial systems, whatever kind, to an open mainframe project to get started on building applications. Let's go share business data. Let's share the chart of accounts. Let's figure out how to share a ledger. That's another initiative I've tried and would like to continue further. Share information about ledgers and share ledgers. Let's go make the world a better place, enabling 1 billion new people to improve their lives by coming into the digital economy, by having measurement systems that help them track what they do and inform them what they could do better and how they could do it, and do it at low cost. And they don't have to understand finances. These systems can do it for them. This is Conversations with Kip. Thanks for listening. Love to have your feedback. Have a good day. What's a mainframe? For those of you that may not know, let's talk about it briefly. If you go back to 1959, there were rooms full of stuff. In 2017, when I recorded a segment on my blog with Jim Latashevsky there, it looks more like a refrigerator behind us. They're just a server. Z is the IBM name for its mainframe hardware. There are many operating systems that work on Z. One is the flagship system is ZOS, which has probably the largest system, the largest number of customers. CICS, DB2, COBOL, all of that is a typical ZOS environment. There's a very old operating system called ZVM, which is a virtual machine, one of the original virtual machines. Quite often it's used, it can host any of these operating systems, but quite often it hosts the Linux instances. So smaller individual instances for Linux hosted under ZVM. If you go down this list, one of the systems that's highest performance, lowest number of customers would be ZTPF. And that's a very high transaction processing facility system. Very few customers, but very demanding uses of the system. In some cases, people might even class what was termed mini computers or mid-range that were smaller than mainframes when they were introduced, but it was before the advent of PCs. System I in the IBM nomenclature is one of those systems, also known as AS400, has many of the characteristics of Z and still a widely used business system in many locations. So here's the quote that Stuart Alsop unfortunately gave and gets picked on because he gave such a specific date. He wasn't alone in his predictions, but he gave a very specific date on February 22nd, 1993 in InfoWorld. He said, "I predicted that the last mainframe will be unplugged on March 15th, 1996. But Arcadi Mainframe Yearbook Survey of 2019 showed that there's a lot of growth in mainframe usage. These are customers that are planning to grow their usage of the platform. And there's, 8% is going to have a decline. 8% will have no change. But other than that, you've got 84% there that's having growth. Some of it, substantial growth in mainframe. But the mainframe has certainly been impacted by recent developments. And one of the big impacts has been open source. And open source, mainframe developers have known that open source was impacting IT systems for decades. This was an interesting quote to me by Holger Mueller. He said when he realized that open source was going to win was somewhere in the early 2000s, Oracle dropped its multi-year 1,000 plus FTE effort on an application server to use open source Apache going forward. Next, in 2013, IBM's Dabby Sabbath shared that IBM was basing its next generation PaaS, Bluemix, on open source Cloud Foundry. Holger says,
When enterprise software giants cannot afford to out-innovate open source platforms, it was clear that open source was winning. So open source is having an impact on the mainframe, but let's look at the impact open source is having on proprietary systems. This survey from Tidelift and NewStack, 400 professional developers were asked to compare open source and proprietary software. And you can see out of this survey that open source was clearly deemed better by these developers. Remember, they were all open source developers, but the prior statement was very clear as well. The one place that it's not true is on reliable support consulting services. That's an opportunity for someone to make a big difference there in that space. But not everything has been impacted. I think Frank Scavo, commenting on Mueller's blog post, said, open source needs a large set of potential users, but enterprise applications do not have as broad a potential user base as infrastructure software. Although ERP market is huge, when you break it down by specific industries, it is small compared to the market for, say, Linux. So on the far left-hand side here, I drew this pyramid with infrastructure at the bottom, which has been widely impacted by open source initiatives. And those are continuing to grow in the middle space of utilities, common applications, OCR, CAD, Office applications. More and more we're seeing more and more things impacted by open source. ERP systems, though, even though there are open source ERP systems like Apache OFBiz, they're not very impacted yet because, like Frank said, the number of users are smaller. In the center of this, though, if you take the orange line as a representation of what the growth in open source and its impact it's been having, right? And the white line is proprietary software. It's clear proprietary is declining. Open source is growing. If you laid out, though, how this works, Ginny Rometty in 2019, IBM CEO, said, Chapter 1, which might be infrastructure and utilities, of the cloud represents about 20% of the workload opportunity. It was largely about moving a lot of new and customer-facing applications to the cloud. Chapter 2 is about the hard stuff. So, on the far right-hand side, what really remains to be done is much larger, much, much larger than what has been done. The pyramid's really upside down. The impact to be had is much, much larger. So why hasn't it changed? I mean, you've got the number of users is one thing, but I think there's more than just the number of users, because there have been organizations been attempting to move open source, move off of mainframe applications for a long time. And pondering that, on the far left-hand side here, I did this analysis. You look at computing cost from the time of the IBM System 360, the first generalized mainframe system, 1964. In 1964, a gigabyte of storage cost about $7 million. Well, our financial systems were automated in this up to perhaps the 1990s was when most of these systems and the cost were very high through all of that automation. It was done in such a way as to preserve and reduce the use of hardware and to optimize the systems to be able to get your value out of such a high cost environment. But when we look at what's been automated since then, on the right-hand side here, right? Things that are automated more recently include things like web searches and social media and e-commerce and those kinds of things. The white in this chart represents functional requirements. The functional requirements are fairly low for those applications, as we noted in the video. If we take the functional requirements for financial applications, it's much higher. So when you add using redundancy as a way to overcome the error rates of the platform, you end up with a functional requirement, a complexity that is too high to maintain. Thus, financial applications have not been, by and large, converted because redundancy as an approach to overcome error rates makes them too complex. Okay, so how is the mainframe going to be impacted by open source? How might it come about more fully? Well, if the 20% which has been done comes from the Linux ZVM side of the platform, right? And the yet to do, the 80% yet to do, comes in and affects CICS. That's still the CICS DB2 COBOL pieces that yet to be affected. The thing that's interesting in the middle here is this Unix system services that's been around a couple of decades now on z/OS. It's a Unix implementation. It's a POSIX compliant, not Linux, but Unix. You can see that it's starting to pull applications that are developed in the open source world onto z/OS. And that impact, I think, is going to grow, that the data and applications in z/OS are going to start to get impacted more and more by this space in the middle here, Apache Spark, Java, Python, Docker, Jupyter Notebooks. Those are just some of the things that are moving into the z/OS space that came from the open source world. The Linux Foundation, which was began this project, began something called the Open Mainframe Project, was focused more on Linux on Z, really. But over time, the projects that are contributing, and one that I'm working on is GenevaERS, it really sits more in the z/OS space. It's more part of the z/OS side of things. And that's continuing to grow. We'll see more and more coming from the open source projects. Okay, one last comment that I've been asked a few times is how does someone live off of open source? Well, there is an economy to open source. This is the way I look at it, because everyone has to eat, right? The financial incentives provided by direct proprietary customer interaction, proprietary software interactions with customers, in many cases, it fuels much of the innovation that happens because customers will pay to solve specific problems, and vendors are involved in building those applications. But after those things have been built by vendors, others become aware of them, and they tend to get embedded into open source platforms over time. Kevin Rawlings, the CEO of Dell Computers, once said that PCs were like groceries. The older they got, the less valuable they are, and it's true for software features as well. The older they get, the less valuable there are. So over time, more and more of these features that were embedded in proprietary systems get embedded into open source platforms. If the vendors do not keep up their innovation, they can be eclipsed by an open source platform and become irrelevant. So the vendors have to continually work ahead of the open source platforms to advance into new space, new territory, new problems to be solved. That process of vendors continually adding and it then getting absorbed into the open source platforms is what builds this foundation upon which so much innovation can thrive. And it's so broadly based because many, many people are attracted to those platforms. That's the way people live within an open source environment, in my opinion.